In this lecture, we discuss on mapping and window viewport in geometric models. Now, first of all, mapping of geometric models. Now, in CAD modeling, user inputs the graphical information with reference to the working coordinate system, or say WCS of the sketch plane. While this CAD software stores the graphical information in the model coordinate system, or say MCS. Now figure shows the difference between model coordinate system MCS and working or user coordinate system WCS. Now many times due to geometry, orientation and size of the model, it is highly convenient for the user to input geometrical data with reference to the working coordinate system as shown in figure. Model coordinate system is the only coordinate system that the modeling software recognizes when storing or retrieving the graphical information in or from model database. Therefore, modeling software needs a tool to convert this graphical information from one coordinate system to another coordinate system. Mapping of geometric model change the graphical description of model from one coordinate system to another without changing the position, orientation, size and shape of the model. Just like geometric transformation, mapping also play central role in geometric modeling. Geometric mapping is used in modeling, analysis, animation, etc. Now let's discuss on geometric transformation and geometric mapping. Geometric transformation changes the position, orientation, size and shape of the graphic element. Now, geometric mapping changes the graphical description of the graphic element from one coordinate system to another without changing its position, orientation, size and shape. Geometric transformation involves changes in graphics elements in same coordinate system. Geometric mapping involves changes in coordinate system of same graphic element. Now, geometric transformation involves one graphics element and one coordinate system, whereas geometric mapping involves one graphics element and two coordinate system. Next, we discuss on window and viewport. Now, when the geometric model is complex and crowded with intricate details, it is difficult to read. In such situations, it is convenient to display only that portion of the geometric model which is of interest for the user at that point of time. This can be effected by window and viewport. Now, first of all, we discuss on window. Window is that portion of the geometric model or object in model coordinate system which is selected for viewing or display. It is an area enclosed by a boundary as shown in figure 1. The window gives an effect of looking at the portion of model through a window of selected size. The technique of selecting portion of a geometric model for view is called windowing. Generally, Window is a rectangle in a standard position with the edges of rectangle parallel to the coordinate axis of model coordinate system. In some software, the other shapes like polygon or circles are used as boundary for window. However, as such shapes take longer time for processing, they are not used commonly. Next is viewport. Now, viewport is an area on a screen in user coordinate system where contents of the window are displayed as shown in figure 2. Viewport is again a rectangle in a standard position with the edges of a rectangle parallel to the coordinate axis of user coordinate system. While the window defines what is to be viewed, the viewport defines where it is to be displayed on the screen. The contents of the window can be enlarged or edited in a viewport. Now this one is difference between what is window and what is viewpoint. We discuss already in last slide. Now next we discuss on window to viewpoint transformation. Now these are the some steps which are used for the window to viewport transformation. So first of all we say that mapping of geometric model from a model coordinate system to a user coordinate system is referred as viewing transformation or window to viewpoint transformation. Now we divide this into some basic three steps. First one is translate window towards origin. Second one is resize window to the size of viewport. Third one is translate window. Now here figure 1 shows the window and figure 2 shows the viewport. Now XW and YW is a point on window, XV and YV is a corresponding point on viewport. Now normalized point on window is given by XW minus XW minimum divided by XW max minus XW minimum, and Y coordinate is given by YW minus YW minimum divided by YW max minus YW minimum. Similarly, normalized point on viewport is given by XV minus XV minimum divided by XV max minus XV minimum, and Y coordinate is given by YV minus Y minimum divided by YV max minus YV minimum. Now the relative position of the object in window and viewpoint are same. So we compare these x coordinates of window and x coordinate of viewport. So we write xw minus xw minimum divided by xw max minus xw min is equal to xv minus xv minimum divided by xv max minus xv minimum. Similarly, for y coordinates we write yw minus yw minimum divided by yw max minus yw minimum is equal to yv minus yv minimum divided by yv max minus yv minimum. So from this two equation we say that from first equation for x coordinates we find xv and for y coordinates we find yv. So first of all we calculate xv as equal to xv minimum plus xw minus xw minimum into sx, and yv is equal to yv minimum plus yw minus yw minimum into sy. So here Sx is given by xv max minus xv minimum divided by xw max minus xw minimum, and Sy is given by yv max minus yv min divided by yw max minus yw minimum. Thank you.